RECOM. We power your products.
My name is Michael Schrotka, Product Manager for AC/DC standard power supplies at RECOM. And I'm here with my colleague from the Field Application Engineering, Moss, who will show us the behavior and the performance of our eFuse today. So can you explain shortly what we see here?
Well, in this setup, what we have is that we have components like our RACPRO AC/DC converter. It is connected to our latest model eFuse.
So Moss, let's have the situation why we usually select eFuses. Power supply is running smoothly, but one of the loads, one of the channel gets into overload or even into a short circuit.
In this case, you can see immediately this channel goes into protection mode. Channel 1 gets isolated while the rest are staying intact. So even on our scope we can see channel 1 is 0. Other channels are still at 24 volt.
What happens if the short circuit disappears again?
So it has auto recovery. For example, we have different modes here. Now it's in recovery hiccup mode. So then we put back the load, it comes back again normally.
And the whole system runs smoothly again.
Yes. We have competition, let's say the competitor 1. This, let's say, short circuit situation affected all other channels. Wow. So it propagated through whole outputs.
So Moss, can you show us the situation when the power supply is not properly selected? Let's say the power supply is undersized and one of the channels gets an additional loading, so would drive the power supply into overload.
Yeah, sure. So channel 1 and 2 are fully loaded and channel 3 half loaded, and after a while, which is 5 seconds, because this unit has a boost power. You see here, the channel 4 got isolated. Because channel 4 has the lowest priority in our architecture.
Okay.
So in our architecture, we have a backward, let's say, priority listing. So channel 4 has the least priority, then channel 3, and so on.
Okay, and what happens if the load comes back to 5 amps, to the standard load?
Yes, good point. Now when we put it back again, it recovers itself.
So can you show us how the competitors perform when the power supply is in overload? So if the loads together draw too much current?
Now you see here, completely the function, you see that there is no, let's say, sequential shutting down the output. There's no priority, no intelligent power shutdown for outputs. Okay. So it's completely random. This is completely random.
Let's see the situation for a system startup. Typical behavior if the complete system is in silent mode, in sleep mode, and then we need to ramp it up, especially if one of the channels sees heavy capacitive loading. How would it react?
Yeah, so here for this setup, we brought a big capacitive load, 33 millifarad.
Yeah.
So we connected to our channel 1. Now we are enabling it, so it's fully charged. Now we see how he handled this huge capacitive load. You see here, very smooth ramp up and complete constant current mode, fully charged the load, and we see the other outputs are, let's say, intact with zero affection.
How do the competitors perform with their capacitive heavy load startup? How about bigger systems? I see an eFuse here with 4 channels. If a system requires 6 channels or 8 channels or even more, how could I set up such a system?
So we have to consider, we have to size the power supply accordingly and the proper sized gauge wire to make the connection. So for here, since we are using a spring clamp without using any tool, we just insert it in. So this one,
Directly to the eFuse without any another terminal blocks or?
Nothing, no terminal blocks, no joints, nothing. So easy.
We power your products.